The idea of a smart city is a broad one, but the main key components that make up a smart city are communications, connectivity, critical infrastructures, sustainability, and security. By integrating multiple ICT assets and the Internet of Things in a secure fashion, the goal of a smart city is to manage assets over a wide array of industries to better the lives of millions of people in a particular area. Smart city, in fact, is a growing industry, so to speak. According to Frost & Sullivan, the smart city market is estimated to be about 1.56 trillion by 2025. Vertiv recently identified smart city as one of the world's most critical industry, alongside with telecommunication, mass transit, and utilities. Smart cities are identified based on its financial, societal, and the economic impact of disruptions. This highlights the need to have the right infrastructure to support any smart cities deployment and initiatives. Data centers are a key backbone of a smart city, as it requires critical infrastructure to store and process large volume of data from multiple sources. Today, a huge potential to make smart city work is the growth of edge computing. The edge represents entry point from various devices, which we are very familiar with, such as smartphones, tablets, and wearables. With smart cities, we are seeing an exponential growth of the number of these devices, which makes edge even more vital. The cornerstone that enables edge computing to function efficiently is the micro data center. It is actually an integrated devices with plug-and-play features designed for branch and remote offices. In some areas, this can serve as data centers. On our journey towards smart city, micro data center will be the silent partner in the background to keep the lights on. With the role of edge computing in enabling smart cities, Vertiv has worked with third-party and independent research group. We have studied 100 cases of edge and identified the top 4 archetypes in terms of its criticality. The 4 edge archetypes are: number 1, data intensive, where it encompasses cases where the volume of data is so large that layers of computing and storage are required in between the endpoints and the cloud, so as to reduce latency and bandwidth. Examples of these archetypes are smart city, virtual reality, and high-performance computing. The second archetypes are human latency sensitive, in where applications of latency negatively impact the experience of a human using a technology or service. Example of these archetypes includes smart grid, real-time analytics, and defense force simulations. The third archetypes we are looking at is machine-to-machine latency sensitive. Pretty similar to human latency sensitive. It's just the tolerance of the machines, the tolerance of the latency in the machines is lesser than the humans because of the way machine processes the data. Examples of these archetypes are autonomous robots, drones, and smart transportation. The last archetypes we are looking at is life critical, where applications affects a human's health and safety. And usually in these applications, it requires very low latency and a high availability requirements. Examples of these archetypes are smart retail, augmented reality, and web OS optimizations. So all these 4 archetypes represents an important first step in defining the right infrastructure in enabling the edge computing for all the smart cities. I believe that the different type of edge archetypes that we have identified earlier, it gives the IT manager a better understanding of the edge, how it works, and how critical infrastructure are needed to support them. It also guides decision makers to make sensible business decisions on the type of infrastructure and configuration needed to support each of these archetypes. Regardless of any verticals, be it in healthcare, retail, transportation, and even government, ultimately the goal is to optimize and leverage on local data hubs, store and process information closer to the proximity of the source. Micro data center that leverages on compute, storage, and communications, aligning with power protection, environmental controls, and even security would definitely be very critical in supporting all these smart city initiatives.